So earlier we talked about contrasting Java IO streams with Java streams. Now we're going to talk about contrasting Java streams with Java collections. And I'll once again talk about this conceptually, and then I'll show you an example that compares and contrasts how you program with Java collections and the form of programming most common to people doing traditional Java. And then we'll talk about how to do the same program with modern Java and Java streams. So first, kind of obvious statement, a collection is not the same thing as a stream. Unlike Java IO streams where the word stream appeared in it, the word collection and stream seem different. And in fact, they are different, although we will see that they can be used together as well. What is a collection? A collection is an in-memory data structure that's typically used to store, retrieve, and manipulate groups of elements. So we can have things like array lists, like I show here. We can have things like various types of hash maps. We can have tree sets. We can have linked lists. There's all kinds of different collections that exist in Java. You can sort of think about a collection as somewhat akin or somewhat analogous to the contents on a DVD. For example, you can read the content from a DVD. You can write the contents to a DVD sometimes, depending on what kind of DVD you have or CD you have. In contrast, a stream is a fixed size pipeline that processes elements on demand. And a stream can manipulate elements that are obtained from a collection or from somewhere else without having to explicitly iterate over them. Java stream is somewhat analogous to a flow of elements in a video stream in the sense that the content is processed as it flows through the stream. Again, these analogies are not perfect. Typically, contents on a DVD are persistent by their very nature, whereas the contents in a Java collection aren't necessarily persistent unless you persist them. And there's some other differences as well, but you get the basic idea. They're not the same kind of entity, same kind of abstraction. Needless to say, because they're often used together in the same program, there are various factory methods that exist that can convert collections to streams, the most popular of which are the .stream and .parallel stream factory methods, although there's about another dozen plus factory methods that convert various things to streams under various circumstances. And there are also other so-called terminal operations that can be used to take a stream and convert it back into a collection. And by far the most common of those types of things is the collect terminal operation. And we cover that in much detail later in the course. So let's take a look at a simple example to kind of show the differences, to compare and contrast a stream and a collection. So this is a program you can get at my GitHub repository in the EX41 folder at the link at the bottom of the slide. And this particular example here, which is the one that's the non-stream version, also demonstrates so-called external iteration, which is in contrast to what streams do, which is so-called internal iteration. There's a nice article here at this link that talks about the difference between external and internal iteration, and I'll talk about it briefly here. So this particular program starts out with an array of URLs represented as strings, and then we go ahead and we convert the URL array into an array list, which is mutable. That's why we use new array list, because we're going to mutate this thing, as you'll see in a second. If we just said arrays.asList, it wouldn't be it would not be immutable. It would be immutable. We couldn't change it. The next thing we're going to do is we're going to use a good old-fashioned Java range-based for loop with a loop counter to iterate through the list explicitly. And each element we look at, we're going to check to see if it's got the CSE.WSTL substring. That was the old university I used to teach at many years ago. So I used to have a lot of stuff on the website there. And you'll notice that we do this check. We get the item and we see if it contains that substring. And if so, we remove it and then we continue. So that's kind of showing how you can get fine-grained control of looping with external iteration. If it does contain the CSE.WSTL substring, we then go ahead and replace CSE.WSTL with Theory.Vanderbilt, which is my current website. And we set the value into the URLs list or array list, which is why we had to make it immutable, or make it not immutable, make it mutable. The downside with doing things like this, although we've all written code like this undoubtedly along the way, is it's tedious and error prone to write, it's tedious and error prone to read, and it's also difficult to optimize. If we wanted to make this run in parallel, for example, we'd have a lot of work on our hands to do that. So let's take a look at the alternative way of doing things, which uses streams. In this case, we're doing the same thing. We're going to take the contents of that array and then do the replacing, but we're going to do it more declaratively using Java streams. And this particular example shows the use of fluent interface where we chain the various methods together. It also shows internal iteration because we're not externally iterating through the contents with a loop, for example. And then finally, it also shows the chaining of transformations. And we'll see how that plays out here in just a second. So the first thing we do is we use the asList factory method on the arrays Java utility class to convert the array into a list. And then we convert that into a stream. So now we have a stream. And then we go ahead and filter and transform each element, first by getting rid of things that don't include the CSE.WSTL substring. And then the next thing we do is we go ahead and we replace the CSE.WSTL substring with the DRE.Vanderbilt substring. And the final thing we do is we collect the stream values that have been replaced into a list, and we store that in our list of strings. So this program, unlike the one before, is declarative, not imperative. It uses internal iteration, not external iteration. And because of this, it's very easy to do other things. One interesting thing to note is, like an iterator, a stream can only be visited once during its lifetime. So we have to make sure you don't try to use the same stream without using a factory method to create it from its input source again. One of the nice things about using Java streams is they simplify the chaining of transformations. So if we want to convert this into a list of URLs instead of a list of strings, all we have to do is just add another map method that takes a string and uses the URL new operator. This is what's called a constructor reference in order to convert the string to a URL. And you'll notice some funky little syntax here with this little adapter method called rethrow function, which is essentially used for what's called exception laundering, to convert checked exceptions into so-called runtime exceptions, which I think work a lot cleaner in streams. And you can read the Stack Overflow link at the bottom of the slide for more information about this particular approach. And you can also look at the code in my GitHub repository to find the whole way we handle this type of exception laundering. Another nice thing about using streams is making this run in parallel is absolutely trivial. We just replace .stream with .parallel stream. Now, obviously, in this particular example, that's wildly overkill. There's no need to use parallel streams for 3 elements. But imagine we had a much bigger set of input. We might get a win from doing this in parallel. So that's the end of the discussion contrasting Java streams with Java collections.